Record now. Okay, it's recording. All right, I'm live. Can y'all hear me? Can y'all hear me? All right, so today I'm gonna be mainly going over the usual. I mean the Ionel Dinu's Aether paper. Because again, I just forced myself to get over it while going over each part you guys have questions and so on. Because it's gonna be quite epic. And I think yeah. Anyways, I'll wait till anybody's in here. So we have two people in the stream. All right. Let's go. Let me know if you guys can hear me. I'll check the audios. Actually, audio should be all fine. Check this. And I think yeah. Anyways, I'll wait till anybody's. The audio's fine. Okay, audio's on there, fine. All right, so you guys should be able to hear me. I'll check the Twitter thingy. So I'm streaming everywhere. And then yeah, I had a bunch of some stuff people tell me to search up and stuff. But the other part is like, y'all can search up your own stuff. Anyways, and now here's a threadcast as usual. I'll be posting the same links in there and in here. All right, I'll set this up quickly. I'll set this up like this. Put this in the leave comments. I'll put this here, and also I need to make a second one. Okay, and then put this right here. There's this one. All right, so this would be MES links like that. All right, and this would be like that. All right, we are good to go. Threadcast, put this in. Okay, here's the link I'll be going over. So Ionel Dinu gave me permission to put this in, and I mean to put it into the Hive blockchain. And also another cool thing about the Hive blockchain is there's this cool Hive Pulse. So if you go to Hive Pulse, if you're on Hive, you can literally just switch to any Hive front end. So if you don't like Peaked, you just go switch over to Inleo. And the cool thing is because Inleo, if you post on Inleo and you or you upvote people that posted on Leo, you earn Leo as well as Hive. So anyways, you can flip over. So this is the same article flipped over. If you don't like this one, you go here and you switch to Ecency, and it's actually quite absolutely amazing. And it shows you the voting power right now. It's 22%. Yeah, so it looks like this. But I like the Peaked has the yeah, it has the most features, but it's just the most presentable, like because it can do a lot of different formattings. The other ones I keep asking the Inleo team to change the formatting, but they just to allow like everything. It's like they don't have the ability to have a keyword link. For example, this is an automatic embed. I'm like, I don't want that. I want a normal link like this. See that? This Aether sense as opposed to an embed always. Anyways, all right, so we have 4 people, and also got in the chat if you're if anybody does show. Oh boy, there it is. Oh, Holo Cal. Thank you so much, Matthew, for giving us 4 hours of Judy Wood. Yeah. Timothy Sullivan's in the house. Let's go. Yeah, Timothy Sullivan, yeah, he had some good silver buy silver metal prediction. It's pretty good. And I saw your message saying buy silver metals. And definitely I might ask the Inleo team to put tokenized silver because I just like using the blockchain, so I don't need to deal with the bank or anything until when I ever need to. So for example, if you go to Hive Engine, you can see like I bought tokenized gold they offered. So I buy tokenized gold and I get I think 12% or 50, yeah 12% bonus API boost for life. So I get every day it gets paid out in T gold. So it's quite ridiculously amazing. Anyways, yeah. So hope you guys enjoyed the stream with the doctor, and she might be joining in the New Year stream as well. Because so apparently she was also writing another book. She had like apparently 400 pages of another book, but she never published. Slash her Mac got destroyed or something. But anyways, so it's gonna be on the first responders. So I'm trying to I basically made a Word file for her of all this, and she's gonna be trying to get her notes back up on there, and then maybe sometime in the new year she'll join for a live stream on the first responders testimonies because some of them are quite amazing. And speaking about that, I do want to play this one. Yeah, I do want to play this one, and then maybe share it with the other. Yeah, this one here. Someone commented here, and then I'll go. Basically, today's gonna be mainly going over the fundamental, yeah, fundaments of theory. I think he's like Italian. It's like fundamentals or fundaments of a theory of ether by Ionel Dinu. I'm gonna go over that power, most of that. But I just want to go quickly. Also, Veritas is retiring. Interesting. So he's a spook as usual. And then I want to go over this is a comment someone made. Yeah, this guy right here. So Art Spiegelman, Disaster is my muse from American Masters PBS channel. Start at 119.42. So if you click this, listen to what they're
Turned to
saying.
see the towers. At that point, the other tower was on fire as well. And what we saw was so astonishingly unreal looking.
My dad and my mom as well, witnessed something that you never see in the footage of 9/11. It looked
Okay,
like
it didn't see in the footage of 9/11. Okay, this is listen to her.
footage of 9/11. It looked like all of the gray of the tower fell first, and then there were these bright red beams that hung in the air for a really long time, and then those bright red beams slowly disintegrated. And
Disintegrated. Okay, so she's talking about the core columns, the spire, literally like glowing, yeah, basically glowing and then disintegrated. So this is some advanced direct energy weapon stuff, and it's very very similar. And she said red. This is very similar to the ARA setup.
I remember seeing that so vividly. And the fact that my dad saw it too and then drew it is really beautiful.
So and they drew it. Okay, this is unbelievable.
Equally terrible.
Yeah. Okay. So that is one of the greatest testimonies, and they drew it. So in other words, that's what they saw. But she said it doesn't show in the footage, but that's what they saw. That's quite amazing. I'm gonna put this here, and then I'm gonna go and put it here as well. And also with this, I'm gonna do summarize. So use AI bot to summarize the YouTube video. Art Spiegelman. So that's absolutely ridiculous testimony. So I'll be clipping that definitely and send it to Norman. Is this theory of ether related to Einstein cosmological constant? No, I haven't looked at that. No more echo. Okay, Bill's Schwant. Yeah. So I think I figured out the echo. The echo because Teams. I figured out I had echo before in Teams. And then I realized, okay, the issue was I need to separate the. Well, it's not with Teams. It's with Prism Live Studio on a Mac. Mac basically combines all the audio as one, like the Mac, basically the screen recording with the Teams. So then I had to do it separate, and that was fine with Teams in the past. But then I had one made for Zoom, and then and I think the reason is because I kept it there, and then I did it for Teams. But I think you can't have Zoom and Teams at the same time. So anyways, so you need to, so I deleted the Zoom one. And basically when I do Zoom or Teams, I have to delete one or the other. So yeah, so anyways. Okay, Bill, Schwab, okay, you guys know each other, interesting. Yeah, so no more, is this theory related to Einstein cosmological? Indirectly, but that's, I think eventually you can wrap that around. But this one is just some aspects of this that I think are very, very, very telling about how a lot of stuff happened, a lot of phenomenon happened. Even quantum mechanics, it just helps explain it without a lot of the woo-woo in mainstream mechanics, which is like it's particle, it's a wave, it's all this, it's a charge. No one knows what a charge is. No one knows what a particle is. It's like anyways. So we'll go over that. But I want to quickly see what else we had in the other notes here that I had some people. I just want to go over quickly. Some people were asking, okay, this was relativistic. Okay, this was a theory by, I think that guy that was on it before. Unified Field Theory by Drew Truscott. So here's a PDF here. So Unified Field Theory by Drew Truscott. I went over it. It was pretty interesting. Basically, setting up this big giant formula, and then for each specific type of environment, you can remove them, but and to get to those. But anyways. He's working on something pretty interesting. I'll just share this one. I don't have too much time to go over that, but if you're interested, I'm just gonna put the PDF in here. So I'll put the PDF there, like that, and I'll just copy this message link, and I'll put it in here. So anyways, yeah, basically get on in Leo, guys, on Hive. Wave theory phenomenon. Yeah, but this one is I think. A bit closer to the truth. Yeah, it is ether like it's just basically ether waves and whatnot, but it's longitudinal pressure pulses, which can give rise to basically the whole idea that radio waves are actually electrogravity, not electromagnetism. That's the thing that and the other part is that light isn't in a wave as you typically see it, but it's more in a filament. And you, because the thing is, you see basically electricity and light are like the same thing. I'm gonna go read over this entire paper. just so I can wrap my head around it. So basically, light is just this. It's like the actual, it's like sound of the ether. But then, anyways, there was and this basically, see, so the light the mainstream always shows like the wave patterns, but it should be more, it could possibly be more like filaments. But when you have so much at a rapid pace, you average out as a wave-like pattern, but it's actually more like a wave of the filament. And in this case, you could even have, so I was thinking about what spin is. Well, if you have a filament like this, it could be spinning one way or the other way. So you literally have spin. If you model ether as static electricity, works quite nice. Yeah, but the other part is, yeah, this is for like, I think just helping grasp reality, but also, again, this is light. So this is just a high pressured light, electricity or lightning bolt strike. And the thing is, imagine you see all, so when we're looking at the sun, we're seeing a whole bunch of this at once, so it gets averages out. Similar how white light is just average of a whole bunch of different wavelengths. So, but white light isn't real light. Anyways, it's just an average of everything. Spinning the blossom bowl of grape, I bought one just to spin to see what happens. Interesting. Videotape these. Like when you film it, videotape it, post on my Telegram. I have a chat group right here. I have the chat in there, but just if you have it right now, just film it and then post it on my Telegram, and I'll share it. Very complex math. I'm glad you math guys are looking at this. Yeah, definitely. Because again, I'm very like goal oriented. Goal free energy exists. Everyone's goal should be that, and anti-gravity. And also, I think this can explain a lot of the Hudson effect. Why he got his effects were very like, it's hard to reproduce because it's like he doesn't know when it's gonna happen and all that. And I think because light is not just simple waves. If it was simple waves, I think Hudson would have been able to do that every like basically pinpoint exactly what he was doing and so on. But I think because of the filament nature, it's changing things up. So you have to actually account for that, which most people don't. Anyways, or everybody does. Anyways, so that was this part, and then the other one I wanted to quickly show. Okay, this one, this is a apparently this one is selling. This one was sent to me by Chris Bergier. ECAT the new fire. Apparently this is this guy's selling like some low energy nuclear reaction cold fusion generators or something, and you can pre-order for this much money. And I'm like, can we return to, would they be fully, so after 10 years you could return them or something. I've expected operational of 100,000 hours. So this guy's product guarantee, and apparently you can buy these. And I looked at his Twitter. He doesn't seem to be a spook, so it seems to be very interesting stuff. And so I'm gonna put this here, ECAT, and that's Chris Berger said that to me. So that this one is something I definitely want to look into. And there's research papers, data sheets. And this is Andrea Rossi. Anybody know anything info on this guy? On nuclear mechanisms underlying the heat production of the ECAT. And then there's Andrea Rossi. So he's the one who's developing this. And if you go to his Twitter account, where's the Twitter account? About licensing. Okay, this is Andrea Rossi, CEO of Leonardo Corporation. Okay, and this was inspired by the announcement of the physicists Martin Fleischmann and Stanley Pons in 1989. They have been able to generate enormous heat from an electrochemical cell. Okay. Yeah. Okay, this guy's Dr. Rossi, among others, tried to replicate Pons and Fleischmann, but were unsuccessful. Interesting. Okay, so that's a spook alert. You have to get it right. Nevertheless, he continued to do experimental theoretical effort to produce enormous energy. He eventually found a way that was able to consistently generate excess heat, and the ECAT was energy catalyzer was born. Found out this one to commercialize the ECAT. Okay, so he's saying he couldn't replicate it, but then he got some other setup there. So that's an interesting. And he has a YouTube one here, overview of the ECAT. So this is interesting.
On September.
So this is Leonardo Corporation. 1 year ago, overview of the ECAT test and Latino. Okay, so this would be possibly for another one, and then you can see he had an X account. I don't know what happened to where's that. I'll just subscribe to that, and I'll share this to ECAT the new fire. This is interesting stuff. I'll just put those there. Again, that's Chris Berger sent me that from Boston 9/11 Truth. Rossi's been involved with shady stuff in the past. Not that I care much. Okay, yeah. A Greener has some interaction with Rossi. Okay, so it's again, but if someone's saying you could buy like a pretty much free energy device for cheap, like I don't know, that's something that provides affordable clean energy for 24/7 without need of fuel. Okay, so something's up, and he's commercializing it, and he's still around, and he's saying he couldn't replicate Pons and Fleischmann's. That's what are you talking about here? They're getting railroaded, and this guy couldn't do it, but he got his own little thing, and he's doing fine. So So that's pretty interesting. But he got a patent though. So he has a patent trademark. You see, number 911. Interesting. Apparatus for heating fluid includes a tank for that fuel for communication. Yeah, so basically the ECAT pretty much he has a patent for it. So he has a patent, so it could be interesting. Andrea Rossi. I think I had, yeah, so this is his Twitter. I searched it earlier. Trying to find Andrea Rossi. So he's with okay. Roger Green on Andrea Rossi on. This is ECAT World. Okay, this is the ECAT World. This is the account, and basically they have Andrea. Could be this guy, but anyways, there's ECAT World. So go. You guys can interact with him. Try to sniff him out if he's a real deal or not. But nonetheless, pretty interesting stuff. Because Pontus Fleischmann were definitely the real deal. Fossil history shows a typical gov turn to spook pattern. Fossils history, interesting. Richard Freeman went deep into this stuff. Interesting. Okay, Rusty's been involved. Okay, yes. Anyways, but yeah. So he's been involved in shady stuff. No, let me know because I here at MES. I literally if you find shady stuff, share it because people have to be accountable for that. And then if you can't, if the person can't explain in a proper way why he was doing shady stuff or apologize, then what's the point of it? Anyways, so definitely check that out and let me know what the ins and outs are. But anyways, I'm gonna go over actually one more thing someone asked me, and I just this person, I think this person's like from like forgot where, but some Arab country. I think she keeps asking. This one here. It says, can you find references to the books of these ones? Antenna Theory, Antenna Engineering, Antenna Book. Yeah, so that's all. And I said, I'll have a look Wednesday morning stream, but P.S. I just do random Google searches, and then all you do is put quotes and put PDF in there, and you can find something. I'll do one of them. Antenna Theory. Constantine. Yeah, or Antenna Theory. I'll do this one. Because antenna theory is the reason it's interesting. Yeah, well, I'm gonna search up. It's along the lines of this Ionel Dinu's paper. I knew I'm gonna power through it because it might take a few streams, but it's very powerful. Okay, analysis and analysis design. Okay, I'll say this is third edition. Okay, I found this. Yeah, it's just like people just don't realize. Here's the first. Book. Okay. Yeah. Anyways, that's that one. So this person was asking me for stuff. Okay. Philip. Yeah. Philip V. Join. Okay. Epic stuff. Yeah. There's the chat. You can join it, and then if you put something, reply under here so I can see it right here under this one here in the comment of this current one. Anyways, we're gonna go dive right in. I'm gonna sit down and I'm gonna dive right in. So we have an hour 40 minutes. Actually, I'm gonna. 1 second. There's like a giant turkey being cooked for families over. Anyways, 1 second. I'll be back. All right, I'm lowering my desk. All right, I lowered it, and yeah, I basically opened the window and turned the fan off in the oven, so that I have less background noise. But I do have noise canceling, anyways. Yeah, so I think we figured it out. Okay. All right, put this in BitChute as well. Okay, so anyways, yes, I'm gonna read this. So this was the paper. And again, if you're not familiar with Ionel Dinu, he's been in the MES experiments. So he let me upload his some of his experiments. So this is here it is, Ionel Dinu. He's a I think he thinks he's a physics teacher or something like that. But it's pretty interesting. Okay, fundamentals of a theory of ether. This is the paper. It's the full one. You can download it in PDF and so on. But I think it was. But again, PDFs. I just don't like PDFs. And then this one here. And here's YouTube. And the reason I went over this one, Fundamentals of Ether Part 4, is because he made some modifications to his other earlier editions. Oh, he just uploaded one. Okay, so what are the odds that today? Okay, so he hasn't uploaded in 3 months. Yeah, I didn't even realize. Okay, and the reason I'm going over that paper is because his latest video he links to that one, and he has modified some a bit. So a radio antenna. So read it over, and then he links to this one here where he talks about his paper, and then here is the link to the paper. And then I emailed him asking if I can if I can go over it. He said yes. And now he just made a video. What are the odds that yesterday he made a video, a LinkedIn post, December 12th. Yeah, I'm gonna play this one here. This is epic.
High voltage.
He has an AI talking about it. Okay, so fundamentals of an ether part 4, mechanical origin of electrostatic force. So this is why I'm linking to that one specifically because yes, because he's literally yeah, this is the same one, part 4, fundamental electrostatic force. Let's see, did he change the title? 1 second. I just want to double check everything. Because okay, it's the exact same link there in April 2024. So he still hasn't. Yeah, so he's still in agreement with that because he did make some modifications. So I'm gonna play this right here. I'm gonna play the latest one. So radio waves are electrogravitational waves. Okay, so again, I think he's right. Anyways, let's play this. And he has some AI voice. High voltage and high frequency are what made long distance radio or wireless transmission successful at the turn of the last century. And that's what I'm gonna be going over it as well.
High voltage and high frequency are what made long-distance radio, or wireless, transmission successful at the turn of the last century. Charging and discharging a straight vertical wire, the antenna, to very high voltages with very high frequencies was achieved with step-up transformers. High voltage and tall antennas were the key to Marconi's success in the first transatlantic wireless transmission. The electric currents in the antenna had only a secondary importance. Everyone aimed for higher voltages, not necessarily for greater currents in the antenna. My explanation: voltage matters because antennas emit longitudinal waves in the ether. Electricity accumulated at the tip of the antenna quickly and in great quantity, which is what high voltage is, pushes the ether and creates a compression in the ether. Withdrawing the charges quickly from the antenna creates a rarefaction in the ether. Thus, radio waves are electric waves, not electromagnetic. And, since they are longitudinal, radio waves are in fact electrogravitational. The electric currents in the antenna were not the focus of the experimenters because radio waves are not emitted by the electric currents in the antenna. The electric currents play only a secondary role, they only contribute to the quick increase and decrease of the high voltage at the tip of the antenna. Thank you for reading this important post. Read more at Fundaments of a Theory of Ether Part 4, The Mechanical Origin of the Electrostatic Force. Link in the description below the video.
Alright. So again, this is some MES duality type stuff right here. What are the odds he uploaded this video? And again, this is before yeah, he uploaded yesterday or 2 days ago, and this is literally December 22nd. And it's like it's Christmas time, and this is what we're doing. So anyways, guys, Merry Christmas. This is it's like an absolutely remarkable synchronicity. I'm gonna summarize as well. And why isn't it showing that I clicked the right link? I'm gonna close this. Okay. Government design antenna. I'm gonna actually keep this one open because I might need this design here. So basically, what he's saying that high voltage creates basically high voltage just means high compression of the ether, and then then when you remove that voltage, when you have basically you have one part that's like high compression, other one is off. And then when you alternate that, you're gonna have basically a compression refraction. So you have basically longitudinal waves. And apparently, because mainstream science says that the radio waves are caused by by high current or whatnot. And we'll get to that in a bit. So this is antenna design. I'm gonna copy this. Many people are looking at these types of things right now. Yeah, that's epic stuff. And and think about it. Well, the thing is, the fact that my stream title is literally going over Ionel Dinu's paper, and he hasn't uploaded in 3 months, and then he has does that. And before that, he didn't upload in a year. So we're going a year, 3 months, and then this one. Like, there's some epic stuff there. And yeah, and he has a LinkedIn there. So yeah, so he says I use this channel to present my researches Related to the physics of ether, I consider the ether to be a liquid that fills all space, the outer space between planets and sun, as well as the interatomic spaces of substances in any state, liquid, solid, or gas. I strongly believe that a fluid mechanical conception of the ether explains inertia and can be further used to explain gravitational, electric, and magnetic interactions, as well as the propagation of light. In other words, that any interaction or effect classified as action at a distance can be explained as a fluid mechanical effect in a liquid ether filling that space. Read more at this stuff there. Yeah, definitely. Okay, so we have this stuff. I'm gonna start sharing some more. Okay, this one here. Did I get the right link? Like, what is happening here? Radio waves. This one here. Yeah, I think I just got the wrong link. I'm gonna click the share because the things I always go over and block off the tag there. That's just tracking code or something. Okay, I'm gonna copy this. So hopefully this link works, and then go here. Okay, this encountered. What is going on here? Google, just summarize. I don't have time for that. Okay. Yeah, so that is, and then that's the chat. I just want to leave this here, not the chat. Okay, that's that part. If I need to search anything. All right, so now the second part is, just to give you an idea of how this works, he made this diagram. So a radio antenna emitting electrogravitational waves. Radio waves are not electromagnetic waves. They are only generated by electromagnetic means. In reality, radio waves and light traveling in space are electrogravitational waves. And also, I got Rumble. We have a first comment. How do Matthew get Sachs? How do Sachs? I'm doing well, right? So basically, they are electrogravitational. The calculated radiation patterns at a distance of 10 wavelengths is shown in yellow for various antenna ratios. Antenna length divided by wavelength. So antenna length 200 divided by wavelength 400 equals you get this 1/2. Blue dots along antenna equals electrogen. This is the electrogen one, the additional component he added. Accumulating at the end, basically instead of electricity it says electrogen. Accumulating at the end of the antenna and producing ether compression. So electricity, high voltage equals high compression. So this is the he said element or whatnot producing that equals blue wave fronts. Red dots along antenna equals electrogen deficit accumulating at the other end and producing ether rarefaction. Red washed wavefront. So red is rarefaction, basically like not relaxed state, and then ether compression is blue. The space between ether compressions and rarefactions is a gravitational field. So the space between compression and rarefaction is a gravitational field, and that's because you're gonna have a gradient of the pressure between the two, and so on. So we'll play this right here. See what he has right here. It says program. I asked him for some of these programs. He didn't want to share this, or no, I didn't ask him directly. I think Fractal Woman did, but I might ask in the future. Okay, so it goes up and down. Yeah, so the red are rarefaction, and then the blue is compression. So this is the model like that he made, and you're gonna have compression waves, and you can have interference and so on, all that jazz. But the fact that it's gravitational means you can move objects. You can move levitate a bowling ball. And then the other aspect is the filament aspect. Because right now it's just modeled as a strict wave, but then we'll see what how the filament aspect comes into this. Okay, this is I'm gonna actually go. I'm just gonna play the whole thing, but I'm gonna go speed up. Okay, we're gonna go 2x speed. We'll go faster and faster. See what happens. Okay, we're gonna go on 100x speed. So imagine this super rapid pace, and at like different wavelengths, even at big wavelengths, but they're still going rapidly. So wavelengths of like a meter. You're gonna have some pretty cool effects. Or like or like microwave millimeter. Yeah, this is pretty cool. So you get small, big, and I think that this little thingy just outlining the wavelength of it or something. The smaller it is, this bigger or stretched out. So I don't know exactly what. And this is where MES. I try to explain everything perfectly. So he's just showing everything with no sound, and the other one had a robot talking. All right. Oh, this one's coming inwards like that or something. Okay, so he has them reversed. Okay, anyways, you get the idea. Now we're gonna play the. Now I'm gonna start reading the whole thing. I'm gonna finish the whole thing before I get to any other up there. Unless you have questions here. The water's above. Okay, interesting. Yes, 499. Antenna theory. I think I shared it already. Antenna theory. Did I share it? No, I didn't share this one. I shared it here, I think. Yeah, I'll put it. Anyways, just in case I forgot. There's antenna theory. And then see what happens. And I'm gonna go actually radio waves. In mainstream terms. So because he was talking about that radio waves wiki, and then I'll also make a Grok one, ask Grok radio waves wiki. are wavelengths in the electromagnetic spectrum, typically between here. Um, okay, like all our speed of light, I was going to say, are generated by charged particles undergoing acceleration, such as time-varying electric current. So it's saying that electric currents is causing that. Okay, so this is the thing. It's saying that basically, yeah, the electric current is as opposed to the voltage, and this is where he says no, naturally occurring radio waves are emitted by lightning and astronomical wave objects. So even lightning emits radio waves. Interesting, and are part of the black body radiation. Okay, so currents. I'll say how radio waves are. Let's say radio waves generated by electric currents. And he has some good arguments that saying it's not, those are not the specific reason. Okay, this is the high frequency oscillator dipole antenna. How radio waves are produced. They're saying that as this is accelerating, it's gonna be doing that. Setting it off. I just want to see what the actual mainstream reason is before we go further. Because I had the other radio waves, but I didn't exactly look at the current side of it. Are critical. Different antennas emit differently, so you can have it like that. I'm gonna go and YouTube quickly. It's radio waves produced by electric currents. Okay. Electromagnetic waves by oscillating electrons, so AC current. So let's see what this says. How radio waves are produced. This is a model.
Hi all, this is a short video I've made to show you how radio waves can be produced by oscillations in an electric circuit. Just to describe what you can see on screen, we have a situation here where a radio wave is going to be transmitted from a radio station on the left-hand side over here, all the way to, for example, a house or domestic property on the right-hand side over here. You can see the radio transmitter mast on the left, and there is a receiver mast and aerial on the right. These blue dots represent electrons, which you know are parts of atoms that orbit the nucleus in shells. When we have metals, electrons are sometimes free to move. When an electron moves, it creates a disturbance in something we call an electric field. If we have an electron moving regularly in a back and forth rhythm, we can say having it oscillate, then what we find is that it sends out a radio wave. This radio wave will have the same frequency as the oscillating electron. When the radio wave hits the receiving mast, it is absorbed. At this point, the energy in the wave is transferred to the electrons here, which then also oscillate with the same frequency as the wave and the original electron. Just to show you, if I change the frequency of the oscillation of the original electron, we should see a change in frequency of the electron that receives the radio wave as well. I'll just pull up a little graph to show you this too. So here we go. This is showing the frequency, how often the wave arrives at both the transmitter and the receiver. When I change the frequency, although for some reason it's changing the amplitude as well, we can notice that the wavelength shortens. And
okay, so it doesn't explain, but it basically saying moving charges, current or electrons, whatever, that produces the actual wave. So that's the part where I'm pretty sure is not right now. So I'm going to search up this P hat. I'm going to copy this. Put this here. Summarize. Anyways, yeah, we're powering through. I just want to get the. I always like getting the mainstream narrative first, so that I can be able to explain to normies, or just basically explain to in language that everyone's more like fluent in, and then go to the ether part, because ether you don't want to sound like wackadoodle unless you have some anti-gravity like effects on demand to show people, hey, whatever this guy's doing is right. Similar to John Hutchison. It's like whatever he's saying about his stuff. Oh, well, we gotta listen to him because he's producing stuff you ain't. Okay, I'm gonna go over PHAT radio waves and electromagnetic field. I think why is it? And then 1.9. Okay. PHAT. They should have a model there. This one's pretty cool. Okay, so we have it here. This is the one there. Radio waves. Just run the browser one. Okay, so there's runtime, jars, loading, menus, graphics systems, initializing. Okay, so we have it here. So we have that guy's same exact setup. Just start. Like, what are you all doing? Okay. Oh, this is manual. Oh, here's manual. Okay, so there it is. So basically, as it's going, it's showing there. Now it's gonna go up and down, up and down. I'll make this zoom in. Unbelievable. Like who's making this stuff? You can't even zoom in properly. So I'm gonna go. Yeah. So anyways, it goes like that. You get the idea. Play around with it, but you can't zoom in. Just like people should be in jail. Okay. So as you're seeing it, you notice that. And they all showed it over there. So again, that's not actually supposed to happen. It's actually supposed to come from the top. Anyways, I'll share this. And if you find a better one, let me know. And I'm going to go straight through it into the thingy. And let's see. Tammy says she sent a bunch of videos, radio frequency, programming, and math. Okay, epic stuff. Yeah, we'll get to that in a bit. Let me see what you sent here. And also, if I'm doing a stream, right, put it into the comment section of the post. So that because do you get what I'm saying? Because right now, I think you put it, or you may put it before. Yeah, you have sent a lot of other stuff in the chat, but yeah, but like, but if you send them, yeah, but if you send them now, you can send them right there, and I'll be able to see. But anyways, I'm gonna go dive right in. Yeah, so I get the idea. Basically, current as it moves, and that's here, time varying currents. Basically, they're saying if you move a current, that's producing the field. But this is not necessarily accurate, and I don't, and I think it's yeah, I think it's wrong as well. Anyways, so here's Fundamentals of a Theory of Ether, Part 4 by Ionel Dinu, and again, so I'll zoom in so you can see. This is why I like article format, so you can zoom in and it's readable anywhere. You don't need to do a PDF. We're just gonna mess up the formatting and all that. So anyways, Fundamentals of a Theory of Ether, Part 4. I'm going to read. I read the beginning before, but I'm going to read it again because I'm going to go however many Wednesdays until we're done this. Permissions from the author. So yeah, Fundamentals of Ether. Yeah, Fundamentals of a Theory of Ether, Part 4 by Ionel Dinu. Permission from the author. Ionel Dinu gave me permission to re-upload his paper as an article on the Hive blockchain. The original paper can be viewed on ResearchGate here. Ionel Dinu YouTube here. Ether Science. All right, the mechanical origin of the electrostatic force. This is the title of it. Basically, has all these different titles. You could call it also the nature of the electric field, radio waves, and light, a solution to the wave-particle duality, the propagation of light in channels. That's the cool one, yeah. Propagation of light in channels, helping Millikan explain the photoelectric effect, or electric science without positive and negative charges. That's a big one. And then released April 8th, 2024. I think that was a solar eclipse or something. Last updated June 5th, 2024. I think April 8th. 2024 solar eclipse or something? I think so. Yeah, so we're dealing wonderful weather we have. Okay, interesting. Where are you at, Elijah? Yeah, okay, we have it's okay, what are the odds? His paper is literally released on a solar eclipse. Like when the moon covers the sun. Like what planet are we on right now? All right. Okay, we're on a I'm trying to tell y'all, when things line up, that's when you know you're on the right path. Because reality tells you what to do. Okay, so anyways, so that's just a bit ridiculous. I'm gonna go I'm gonna edit this right now. I'm gonna edit this release. Okay, released on. Okay, I'm gonna put this right here. Released April 5th. Okay. Now I'll say I'll just say on the solar released. I'll put it like this, or I'll put it like this on a solar eclipse. Okay, So that's the first edit I did of this. Okay, this is again that's just it's pretty wild, guys. Like I don't know what y'all doing. So on a solar eclipse. Like what are the odds? Like he's probably like not even not even looking at the solar eclipse, and all of a sudden it's just like, all right, publish, and then realizes it's a solar eclipse. Okay. Okay, so released April 8th, 2024 on a solar eclipse. Last updated June 5th, 2024. Ionel Dinu, bachelor's in physics. So bachelor's of science in physics, master's in science physics, and teacher of physics, QTS. I think it's high school or somewhere. But anyways, so he's got a lot of physics background. Note the giant sunspot on the equatorial plane. Giant sunspot. Oh, this one here. Or where? Oh, this one here. Yeah, this little thing is exploding. Okay, there it is. So yeah, this is kind of what I mean by light is in channels. Like light goes like that. Think of electricity pretty much in light, the same thing. Anyways, we'll keep this there. Maybe I can zoom in a bit better. There's got to be a way. I can't believe you zoom in and it just messes up everything. Like what? Who's doing this? Whoever's doing this should be in jail. It's like, okay, that doesn't even work. Okay, so I'll just keep that loading. Okay, so one more time. Oh, I can zoom in. Nope, I can't zoom in. Okay, no, now it's gone. Now it's done. Oh, I know. I know. You zoom in and then you refresh. All right, there it is, guys. We solved it. We solved the double slit experiment. And then refresh. So the cool thing is, as you refresh, it centers it everything. Okay, so we got it, and we go oscillate. Okay, there's oscillating, blah blah. Electric force on electron, force on electric field. Radiate static field. Let's do a static one. Okay, let's see how static one. Okay, there's the ether setup there. But again, this isn't exactly. Yeah, well, it might be something like that, but I'll go over electron positions. Oh, and you can move it. That's pretty cool. Okay, so we can zoom in and we can do that. I'll manual. Yeah, so manual. Wiggle the electron. Wiggle back and forth. Okay, so we wiggle. Okay, full field. Okay, so we got radiated force. Okay. Oh, that's a cool one. Force on electron. And it goes like that. Interesting. But it's a sideways force. That's an interesting setup. And it goes up and down. Okay, this is some cool stuff there. Full field display. None. Okay, full field. Okay, so we got that. That's pretty cool. That's the force on it. I'll just do electric field. But yeah, so let's do electric field. Oh, field sense. Oh, how did it do that? Force on electron. What is going on here? Curve. Okay, well, there's the curve. And then electric field like that. Okay, anyways, that's pretty cool stuff. All right, and there's an email. You can contact them if you want. dynuionl@yahoo.com. Anyways, so LinkedIn as well. There's LinkedIn. You can interact with him. So again, he's a real person. You can go interact. And I'm pretty sure he's right. Exploring Feynman's potential. You get AC with DC output from these vertical antennae. Interesting. That's something we can discuss. Okay, anyways, abstract. This work is a further development of the theory that explains electrostatic attractions and repulsions by the molecular vibration of objects acting on one another through the liquid ether that fills the vacuum and the interatomic spaces of substances. The 2,000-year-old problem of a mechanical explanation of the laws of electrostatics is answered by the behavior of coupled oscillators. The physical, it's answered by coupled oscillators. I think that's when you have those two oscillating things put together. And this is why I like the stream. I can go and quickly ask what this is, coupled oscillators. In normal modes, basically, I think when you have two things, in vibrating back and forth, coupled oscillator, like a string. So there's two blocks attached to three springs. Okay, basically, yeah. I'm gonna go with some coupled oscillators of different types. Basically, have a string connected to each other. So here's a coupled oscillator. It's stuck together, and you vibrate, and you can interact, and so on. Longitudinal force. This is basically, imagine I have mass with springs, just bounce back and forth. So anyways, that's coupled oscillators. Okay, the 2,000-year-old problem of the mechanical explanation of the laws of electrostatics is answered by the behavior of coupled oscillators. The physical origin of the electric field is that of a to and fro motion. So basically, back and forth motion. of the ether. Light and radio waves are shown to be longitudinal waves consisting of to and fro motions of ether along the direction of wave propagation, which makes them essentially electric waves. Corroboration with results from previous works leads to the conclusion that the complete nature of light and radio waves is that of electrogravitational waves. Again, this is the Hutchins factor. Again, I can pretty much on. That's my putting my where my money is, my mouth or money. Anyways, lower this bit. The 1,000-year-old problems of the photoelectric effect and of the wave-particle duality are solved by uncovering the direct link between voltage and frequency of vibration. So of the photoelectric effect and the wavelength are solved by uncovering the direct link of. So basically, voltage and frequency of vibration by new interpretation of de Broglie equation and by advancing the new theory of light propagation in channels. So light's going in channels. And when you have higher frequency, the photoelectric effect basically, for those who don't know, this photoelectric effect, just go to the image. You want non-linear oscillator to make the holes times the extra electron pairs non-constant. Okay. For homopolar motor, you want like horizontal antenna because it will use Earth's B field like circular. Interesting. For the homopolar, you can ask this is the N machine. If you've seen Richard Hall's setup there, definitely watch that. This is for y'all. This is for Elijah Jack. Richard Hall mini N machine. So someone actually uploaded on video on YouTube. I was gonna do that as well. So he has that, but he's doing a weird hand sign. That's an interesting bug. This person has been uploading them all. Richard Hall N machine conclusion. Okay. No, this guy's he's uploading Dr. Judy Wood. Yeah, Tower Storm. That's interesting. He's got these videos. But he's been uploading these Richard Hall ones, the End Machine, here. Yeah, and he actually made one, and he basically tried to explain the anomalous effects. But the weird hand sign and the ring is a bit interesting. Also, he uploaded this one here. He uploaded me. He also uploaded me, John Hudson, and Carrie Cassidy. That's fascinating. All right. So that'll be where's the conclusions? I'll go to the conclusions. You can watch this, and then you can watch the whole rest of it. But I don't like how they don't put the links. I'm gonna go, or you can just watch here, Richard Hall, Rich Planet, and then go to the End Machine. Exactly, Hall effect, phase conjugate makes wave patterns. Yeah. So you go to he has a live stream set up. Does he actually have a live stream yet? Not yet. Rich Planet TV, all shows. Go to End Machine. Yeah, this is the conclusion of that. So basically, watch these. Anything with the End Machine. So End Machine design and build of these. He has these two. Launches Rich Planet Power. So these past 3 ones, he's focusing 3, 4, and 4, 3, 1, down. So definitely just watch those for Elijah Jack if you haven't already. And he goes over that. But it's a lot of hours. I think you'll like it. And I'll put this here. And anyways, I'm gonna go back into the thingy. So we have photoelectric effect just to quickly show the mainstream side of it, and then go over this guys. But also, I think I got tagged something. Okay. I thought. Okay, this one here. This is RF amplifier. How to read an RF datasheet. Just want to see. Yeah, this is interesting. Yeah, but again, this is something once I develop my Brandy antenna, we'll get that in a bit. But yeah, anyways, I'll just keep it over here. Anyways, photoelectric effect. So photoelectric effect, emission of electrons from a metal plate accompanied by the absorption of light quanta. Photo emission of electrons from accompanied by the absorption of light. Yeah, basically light goes in here, and then it depends on the frequency. And then this can vibrate out. So it's like, it's just basic sound and ether fluid max. Okay, Elijah Jack, thank you for the link. I haven't seen those. Yeah, definitely. You like those. I uploaded a lot of them on my channel here as well. End Machine. If I go here. Yeah, this is here. End Machine. Let's go End Machine. Yeah, this is the latest video. Here's the latest video. I upload all of them as well. PDF. I mean, in video here you can download. Here's the latest video plus testing of Richard Hall's End Machine, which is giving an enormous energy output. So this, and he also shows it running as well. So this is what I like about it. Richard, he doesn't just go and just show you little highlights or clips or talk about it. He has a 3-hour one of it all running, so you can actually go and see it all, and you can do your own measurements. So you can go do your measurements there, and you can just search up End Machine. You'll see everything there. But you'll see these are the latest ones in the conclusion there. So quite fascinating stuff there. And yeah, what's this here as well? Market theory and close NP alignment will help connect dots in the photoelectric effect. Yeah, but what I'm trying to say is that there's no dots, but it's just ether. Depends on the vibration of the ether, and then you go there. Like, think about water. If you go have a hose and you spray it on something, and if you're trying to clean the ground, you need to like increase the speed or whatever, or the frequency, make it super narrow, and you basically clean it out. It's kind of like the water jet cleaner. So it's like basically you have to increase frequency to or the power of it just to clean it. So it's like low frequency. You could think of them as just as just a hose without anything. But then now if you have this power one, you get gamma rays. Think of these are gamma rays. It's firing gamma rays to wipe it off. So and then the electrons that fire off are just basically the setup. Neutrino refraction pattern will overlay the X-ray. Okay, interesting. Okay, yeah, dots was a metaphor. Yeah, no worries. I'm just saying but there are dots there anyways. Yeah, no problem. I'm just saying, I think it's pretty much solved. But then again, we still need to produce something because mainstream still has phones and all that. Like mainstream, you go to mainstream science, you can produce these. Even though on the experimental side, they probably don't even follow the exact mainstream theory. They probably do their own thing, like when you develop antennas and all that. Like where's that other paper there? I had the giant one. Anyways, I'm gonna close some stuff so I can graph. So there's photoelectric effect. There's a couple oscillators just back and forth. And yeah, I'm gonna copy this. Actually, this one's pretty cool. Why can't I just go to the site? Okay, this photoelectric effect. I'm just gonna post everything here. But I just needed the image actually. Image. I gotta put that there. All right, so that's that. And then a couple oscillators, photoelectric effect. And then this would be something else, photoelectric effect. Yeah, this is just this. I'll just copy this. Yeah, anyways, anything and I just copied it and didn't do this. So Macs are just a bit slow. And that's yeah, I don't like how it doesn't. This is like transparent. That's pretty weird. But anyways, photoelectric effect. Okay, and anyways, just send this. Okay, send another one. Send this. And yeah. All right, and upload this one. I'm gonna start standing and then go power through to the video. So guys, this is why reading for me. You kind of have a grasp of how I when you watch the streams, you kind of see how my brain works. It's like when I wanna like put my name online, like for example this paper, every single sentence I just have to go and wonder what's talking about. It's like a math equation. You can't just put a random equation. So and you have to source it, explain it. So anyways, 100-year oral problems of the photoelectric effect and of the wave particle duality are solved by uncovering the direct link between voltage and frequency of vibration by a new interpretation of the Broglie equation. I think that's like the wavelength equation. The Broglie equation. Let's go to the just quick wiki on this. Oh, matter wave. So this is basically why yeah, like you can have matter like electrons and so on acting like waves. Matter waves are a central part of the theory of quantum mechanics, being half of wave particle duality. Okay, at all scales where measurements have been practical, matter exhibits wave-like behavior. For example, a beam of electrons can be diffracted just like a beam of light or matter waves. Or water wave. Or water. There it is. The concept that matter behaves like a light was proposed by this one here. So that's the Broglie wavelength. The Broglie wavelength is a wavelength associated with a particle, with momentum through the Planck's constant. So basically, the Broglie wavelength is equal to the Planck's constant divided by the wavelength of divided by the momentum. So anyways, momentum, inertia are related to the wavelength. In other words, just the frequency of the ether vibration. So that's pretty fascinating. Okay, so anyways, so that's the de Broglie. But again, at the end of the day, we need experiments. And what I like about Ionel Dinu is he has some experiments. Voltage like frequency, currents like collapse of scalar wave. And I think well, he's saying voltage is like the ether compression, scalar wave, and it was two and train water will peak. Interesting. Anyways, yeah, I think it's just a lot of the obstacles are just like language. We have to all try to use the same language to understand the language I'm using because I'm like a very simple person. De Broglie, like what I wrote De Broglie, Broglie or something. Anyways, what else saying De Broglie? Anyways, De Broglie. And by advancing the new theory of light propagation in channels. Okay, that's the key part. Okay, keywords: ether, electrostatics, coupled oscillators, electric field, radio, wireless, electric wave, light propagation channels, matter waves, de Broglie, photoelectric effect, thermionic emission. That's basically when you heat something and emits stuff. Thermionic emission. Anyways, I'll power through. And again, like I'm saying, it will take us however long it will take. Okay. So thermionic emission is the liberation of charged particles from a hot electrode whose thermal energy gives some particles enough kinetic energy to escape the material surface. Basically, you have filament, heat it up, and then particles run away. So you got electrons typically. It refers to emission of electrons. So that's the thermionic. I think we've covered this before, but anyways, I'll be doing this quite a while. Okay, there's thermionic emission. Basically heat it up and stuff fires off. Okay, let's continue for this. So introduction. This work claims to get some water. Okay, we still have an hour to go. Okay, epic stuff. And then yeah, so we'll go through and yeah, and again, bear with me. This is how I learned. And so introduction. This work claims to solve the 2,000-year-old problem of giving a mechanical explanation of the electrostatic force. It is part of a broader project aimed at finding mechanical explanations for all the interactions at a distance, gravitational, electrostatic, magnetic, as well as for the propagation of light through the ether as a longitudinal wave. Explaining electrostatics mechanically has been known historically as the most challenging of all the interactions at a distance, recognized as such by the scientists of the 19th century who were fully immersed in the experimentation and mathematical representation of the phenomena of electrostatics and magnetism. One of them was William Thomson Lord Kelvin. That's the Kelvin scale guy. So the temperature guy. Tungsten bulbs good to use for scalar bleed of stand. Okay, yeah, I think you're like a few levels ahead of me. So although he is remembered today as the inventor of the scale of the absolute temperature, William Thomson's main line of work was in the field of electromagnetism. He contributed to the successful transmission of electric signals through the first transatlantic cable that linked Europe and America. Oh wow! So you have a cable sending signals there. William Thomson was contemporary with the likes of Stokes, Joule, so all these guys. These are all the ones that we used all the units for. The energy guy, Maxwell, and Heaviside, whose works he followed and understood as he did the works of Faraday and Green, who preceded him. Okay, so I need to indent this. Because I copied from the preceded. Yeah, him. So because I copied from the PDFs, and PDF like breaks up the lines for some reason. Anyways, and also I'm gonna go. Contributed to the successful transmission of electro signals to the first Atlantic. This part here, I think there's a typo that he made. Giving a mechanical, but explaining that electrostatics mechanically has been known historically as the most. Let's put a as the most. So this bracket just means I'm putting it in, not his. As the most challenging of all the interactions at a distance. All right, and update. All right, so we updated that, and I gotta go back. It's only the downside of this thing. I gotta go click cancel. All right. And again, that's why instead of the PDF, like think about it, I just edited a real-time thing, and it's on the blockchain. The edits too are on the blockchain too, so you actually can see what happens forever. 1800. I'm like, this stuff is so interesting. I could log 6 hours a year on YouTube about the subject and have epic stuff. Yeah, definitely. But the thing is, it's watching is one thing. You gotta experiment and produce physical things. So the goal is produce a physical UFO. But also this guy, Ionel Dinu, has some cool experiments that I've actually re-uploaded on my channel to help explain his theory, which I'm pretty sure he's right. Okay, where's the part right here? Okay, yeah, so I fixed that up. So he proceeded. He invented important. This is Lord Kelvin guy. He invented important instruments for the measurement of electrical quantities and was involved in the setting up of the electric units of measure used today in electricity and magnetism. British Association, and then here I put the links here. So he usually, if you see his paper, the way he does it, he goes like this. This is what he does. This is why I like having everything like right as close as possible. So if you go, if you see like it's here, it has a link right here, or it has a reference I1. Then you have to go all the way down here to see the reference. What I do, I just put them all together. I mean, I just put it right where it was, so I kind of made it slightly different than him. So I put it here. So I1. This is the reference British Association for the Advancements of Science reports of the Committee on Electric Standards, a record of the history of quote absolute units and of Lord Kelvin's work in connection. So that's a misspelling or maybe old spelling with these. Cambridge at the University Press. Connection. Connexion? Is that a word? I think it means connection. That's probably old language connection word for it. That's pretty interesting. Okay, yeah, it's a chiefly British spelling for connection. Okay, so British are Wilden. All right, so it's a connection. Okay, his positioning in the midst of these scientific activities, both experimental and theoretical, that took place in the second half of the 19th century and contributed to the development of electricity and magnetism, makes his opinions and thoughts extremely important. Relevant to the present work is William Thomson's recognition in his 1889 address, Aether, Electricity, and Ponderable Matter. So again, these are all big names. Talking again, William Thomson is Lord Kelvin. So Lord Kelvin's talking about Aether way back. William Thomson, mathematical, and this is the link. I mean the source here. William Thomson, Mathematical and Physical Papers, Volume 3, Cambridge University Press, Warehouse, London, 1890, page 484. And to me, the references are pretty important too. That's why I read them out, so you understand where it's coming from and how big these names are. Okay, and this is Lord Kelvin, the Kelvin guy, the temperature Kelvin scale guy. Kelvin temperature scale. Oh, actually, I'll go with Lord Kelvin. And his name is Lord Kelvin, guys. You better listen up to this guy. This is Lord Kelvin. And this guy speaks, you gotta listen to him. He's probably some Freemason or something. Sorry, so. But anyways, or just, but again, nonetheless interesting. So absolute temperatures are measured in the Kelvin. So the international unit for temperature is literally Kelvin. And absolute zero is 0 Kelvin. So this guy is named after this guy. And he's writing paper on Aether. So the demand for something like a mechanical explanation of electrical phenomenon is not new, but it is growing in intensity every year. A remarkable thought of William Thomson is his hopelessness that he will ever be able to find a mechanical explanation of the electrostatic phenomenon, or not being able to tell. So again, these guys probably all know about it. There's no lot to say. That's my conspiracy mind saying. Anyways, this is from William Thomson, Mathematical and Physical Papers, Volume 3, Cambridge, and so on. Okay, now with reference to the electrostatic force, the hopeless, I must not say, quote, hopeless. That is too large a word. We are never without hope in science. I was going to use another word, despair. Well, I feel it desperately difficult. I feel the probability of my seeing the solution of it is hopeless. So his seeing the solution of a mechanical explanation of electrostatic phenomenon. And again, electrostatic phenomenon, like just electricity, is something touching your if you have like a high charge in your hands and you get a static shock and so on, or just so electrostatic phenomena. Let's go electrostatics wiki. So let's see what exactly is it doing. Everything has temperature above absolute zero, so all charges oscillate like the time, like the LC circuit waiting to be tapped for emission. Interesting. Yeah, definitely. This is just like a what's a hypothetical. Electrostatics is a branch of physics that studies slow-moving or stationary electric charges. So basically, slow-moving or stationary electric charges where you can ignore quantum effects. Under these circumstances, electric field, electric potential, and the charge density are related without complications from magnetic effects. So basically, you have electric stuff only, no magnetic effects. And it's been known, since classical antiquity, it has been known that some materials, such as amber, attract lightweight particles after rubbing. Yeah. So basically, this stuff here, how do things stick, how do things repel, and so on. yeah, electrostatic field. You have a bunch of different ones, positive. But then, so basically, how do you explain this without positive and negative charges? Like, this is not an explanation. This is not. You can't just say this object has plus and minus, and now that's why they're connecting. Like, well, that's not a mechanical explanation. That's a shorthand. Uh, yeah, basically, it's a shorthand way of describing something that you don't know. We'll just call this plus and minus. We'll say this side connects that doesn't. I wonder what they all thought about the role of consciousness. Yeah, it picks up. Yeah, so I included a link to your paper there earlier. So I'll have look at it later. Yeah, consciousness is an interesting one. So I included the PDF of yours. Yes, yeah, so Drew Cross. Yeah, I included here. I briefly mentioned it. Unified. I went over it. It's pretty interesting stuff there, and yeah. So that's the thing. Consciousness. Again, at the end of the day, how do we apply it to anti-gravity? Again, let's keep going. So that's electrostatic phenomenon. Basically, slow moving. It's stationary electric charges on macroscopic objects. So basically, like on objects like this cat and this styrofoam. So foam peanuts clinging to a cat's fur due to static electricity. The cat's fur become charged due to the tribular effect, basically shaking things. Transfer between when they contact or slide. Electric field of the charged fur causes polarization of the molecules of the foam due to electrostatic induction. Okay, is a redistribution of electric charge in an object that is caused by influence of nearby. So as it gets nearby, the charges redistribute, resulting in a slight attraction of the light plastic pieces to the fur. This effect is also the cause of static cling in objects. Okay, so there's electrostatics. So and so again, I like looking at the mainstream because they pretty much cover all the mainstream terms you're going to get at universities and so on. And then dive. So it's basically, so we have I kind of like acting like a bridge between the what we know is possible anti-gravity and what the mainstream views as possible. What the mainstream knows. So basically, the point I see that keeps coming up is when heaviside condensed original Maxwell equation eliminates some needed for ether function. Yeah, possible, but I've heard that even the that Maxwell's and so on, they don't use them as described in when they actually design the antennas and so on. They use basically, they shorthand it to like literally just ether, the fluid dynamics. They literally just use fluid dynamics part for the stuff. So it's like they simplified just to basic fluid dynamics. So that'll be something. Okay, I'm gonna go right here. All right, so we got the electrostatic phenomenon. So basically, William Thomson, Lord Kelvin, he's saying that it's hopeless to try to solve like what in the world is electrostatics. Okay, so it's hopeless, and he'll ever find out how it is. So the guy who named after Kelvin, the temperature scale, that is hopeless. That you won't be able to explain this. And he's like, how do you explain this without this, without plus minus? Like, what in the world is a plus minus? All right, if you know what a plus minus is, I have a bridge to sell you. Okay, so the illustrations or attempted explanations, the quote illustrations or attempted explanations William Thomson was referring to in the above quote were mostly related to the magnetic effect of the electric current. Okay, so interesting. So there's another one here. My bad. Forgot to read this one here. That was this one here, the hopeless one now. And now we have this one here. I've absolutely not ignored because I have spoken of it 2 or 3 times, but I left out in the cold the electrostatic part, the thing we knew first. Our first love was electrostatics. That is absolutely left out in the cold. We do not touch it. We do not get near to explaining the mutual force between 2 electrified bodies in any of these illustrations or attempted explanations. So the illustrations or attempted explanations that William Thomson was referring to in the above quote were mostly related to the magnetic effect of the electric current, for which a mechanical explanation has been presented in this series of works titled Fundaments of Ether and I5 and I6. I think, was there new references? Did I not include them? I5 and I6. Oh, did I put? Oh, I think I did not put the I5. Okay, titled Fundamentals of Ether, I5 and I6. I'm gonna go. Did I not include it? Okay, I'm gonna open up his paper. 1 second. I think I messed up something. Fractal woman. No. Radio waves. I think I had this book right here. Yeah, this one right here. Okay, I'm gonna go right here. Here's the local one. Here's the PDF of his paper. Did I not include I5? Okay, so I think I need to update these. So I5 and I6. I need to copy this. So you're gonna see me edit real time. This, again, it's why I like articles. You mess up on PDF, it's gonna take you like 30 minutes to update, or you can't update if it's on ResearchGate. So you go here, fundamentals of Aether. So I5 and I6. So I think I thought I4. No, we have I4. We have I5. Where's I5? Oh, I5 and I6. I mean. Okay, there's only one. Okay, so we haven't done it. Okay, I'm gonna edit this quickly. I'm gonna make this smaller. Okay, and then I5. Okay, so I forgot to put the references here. Okay, so there is this one. Okay, and interesting. So the part one, they actually covered fundamentals of Aether. They actually he actually wrote it in conjunction with Fractal Woman, so Lori Gardy. Okay. Yeah. So let's go. How does it look like here? I5 and I6. Okay, there it is. I5 and I6. I'm gonna say this one here. Okay. So then we have I7. Okay, there it is. That was the reference I was missing. All right, and cancel this. I5. Okay, so there's the two right there I wanted to include. Okay, so now we can zoom in. Okay, so we can pretty much zoom in like this. That's way too big for y'all. Okay, so I5, yeah, so the illustrations or attempted explanations William Thompson was referring to here. So we're basically saying that we do not get near to explaining the mutual force between two electrified bodies in any of these illustrations or attempted explanations. And yeah, so these illustrations or attempted explanations William Thompson was referring to in the above quote were mostly related to the magnetic effect of the electric current, for which a mechanical explanation has been presented in this series of works titled Fundamentals of an Ether. You have Fundamentals of Ether, so I5 and I6. So this one, he did the first paper was with Lori Gardy. So Ionel Dinu, Lori Gardy, Fundamentals of a Theory of Ether, Part 1, ResearchGate, August 2020. And then this one, Fundamentals of a Theory of Ether, Part 3. This is when they covered a mechanical explanations for the magnetic effect in the electric current. Yeah, anyways, that might be something we'll cover in a future one. Water will spin with microwaves, by the way. Yeah, definitely. A lot of stuff will, but it does actually an interesting spin. That'd be a good experiment. If you can experiment, videotape it. Let me know. Videotape it spinning and then show it, because again, I like seeing something visually as opposed to saying stuff. Anyways, there's a radio wave. I'll keep that there. I'm gonna close this. Close this. We pretty much covered electrostatics. I'm gonna keep this. I'm gonna move this over here. I'm gonna close this PDF. I'm that one. We have the PDF there in case I need to update. Anyways, so although the knowledge of fluid mechanics was relatively well developed in William Thomson's time, the fact that the nature of the electric current was not well understood prevented everyone from observing that an electric current in the nature of surface waves along a conductor would generate the required circulation of the ether surrounding the conductor, which ether circulation thought constituted the magnetic field that the current produced. So basically, ether circulation is the magnetic component. So basically, this was the mechanical explanation of magnetic effect of the electric current. So as electric current is let's see, this can actually rotate the ether, and I think I'll see if I can find that video. Or we'll just go straight to the paper. So we'll go to his ResearchGate stuff here. I'm gonna keep this open. I'm gonna go to the part, I think part 1 and part 3, but just to illustrate the rotating part of it. Okay, this is his papers. I do want to look at that, but then he has a good diagram of that, or might even just go on his YouTube. Go to his YouTube. This is the circulation part right here. Okay. This is the software that he made, and magnetic field of current carrying coil revealed with computational fluid dynamics of ether. And the way this one, he has an extra electrogen material, and it can spin the ether. So as this is going up and down, you can spin the ether, which detects magnetic field. Anyways, so he used basically you can spin the ether just by vibrating. So this is going around, and he was able to computate this with fluid dynamics. So basically, a if you had like a fluid around this going just moving around in a wave-like pattern, it will spin the ether. So this is the mechanical explanation for the magnetic component of basically electricity. As the current flows, this is the other component, the electrogen he has. If current is this thing that's going side to side, now we'll show you what it looks like. Basically, it looks like this part here. So think of that electrogen as this water around when you have in space or just in zero gravity. I thought he had one here. Again, this paper is going to be quite long, but it's quite intensive. I thought he had a good drawing. Okay, I thought he had. Did I not show it? Oh yeah, this one here. So think of water. So think of the cloth as the metal. Water is electrogen. So think of it like that. This is the electrogen that is that's pretty much electricity. That's the one that's that's able to manipulate the ether. And then if you go back to here, no, where's this one here? Yeah, if you go back to here. So this is that fluid around it. That thing of the water. If it's moving, so it would need to oscillate. Yeah, basically, and it's a slow drift. It's like moving like that, and then that rotation, it will actually create a rotation around this movement around the current will create a rotation. Corresponds to a magnetic field. So, and this is they just made it slow motion. So this kind of motion, what this is showing is that this kind of motion will produce rotating of the fluid. So in other words, you can model, like, this is not just him just making a theory. This is literally computational mechanics, like computational fluid dynamics, showing that a movement around a object like this, that's this fluid-like motion, will produce rotation. So in other words, if the current is moving as he's theorizing, that's affecting the current just by this up and down motion and right to left, it will create a rotation. So that is again, this is not a theory like this. So he has a theory of the ether, but this is, like, you can think of it as a virtual experiment. That's an experiment demonstrating that, yeah, what he's talking about is viable. Like, it's not just he's not going to say, oh, this moves in and makes a circle. It literally showing that is what happens. All right, so that's pretty cool. But I want to get hold of this computational thingy there, and I'm gonna save that as well here. CFD, and here. So I posted it here. Okay, this is all part of this one. So that's extremely important. Like, not toroid is intro to elemental transportation cold fusion. Yeah, but again, I like yeah, Ness Wheels, like, was written. Yeah, but the Bible one it's a bit I think there is some similarities, but the explanation is not the thing either. And the reason basically what I'm alluding to is this Ancient Aliens debunked one. So a lot of Ancient Alien ones. Watch this 3-hour documentary. A lot of the claims they make is yeah. It's a good debunking of a lot of claims being made. But nonetheless, there could be, yeah, obviously some weird stuff happening. But the specific mainstream Ancient Alien ones is just way out of whack. Anyways. Let's go back here. So to keep this in mind, left electrogen, and it's moving around up. If it just goes to, like, slide to the right and up and down motion, it will create a rotation ether. Anyways, so going back in here, simply shine light on spiral and it will spiral polarization shadow. Interesting. All right. All right. So I'm gonna go right here. Okay. So we basically set that. I'm gonna start. I want to set this down a bit. Where did I go? Yeah, so where did I ended up going? Yeah, so and again, this is why I'm saying I'm gonna go over these every Wednesday until I completely yeah, finish this one. Because I the way my brain works, I have to go back and forth and to reinforce my knowledge, and this way you can learn things that maybe Ionel didn't even come across. Okay, so right here, so we're pretty much read that there. All right, so the illustrations or attempted explanations William Thomson was referring to in the above quote were mostly related to the magnetic effect of the electric current, for which a mechanical explanation is represented in a series of works titled Fundamentals of a Theory of Ether. Yeah, so basically, yeah, this one here, I did have a look before, but basically it was that thing I just told you. Just movement like that causes rotation. So that's it. So although the knowledge of fluid dynamics was relatively well developed in William Thomson's time, the fact that the nature of the electric current was not well understood prevented everyone from observing that an electric current in the nature of surface waves along a conductor. So again, surface wave along a conductor would generate the required circulation of the ether surrounding the conductor, which ether circulation many thought constituted the magnetic field that the current produced. And again, he already, as his other experiments showed, the rotation is pretty much the it's very, very similar to the magnetic effects. So if you go to peak experiment, just do I'll just show you the screenshot. So this is Ionel Dinu's thingy here. So rotating cylinders in water behave like magnets. So this is his experiments. Rotate these in opposites, they attract. In the same, they repel. So like spins repel, opposite attract, and this is the same thing with the magnet. Basically, rotating cylinders in water. This one is, they're both rotating. This one is, if you start off like this, they're rotating opposite at the end points. Like when you have them at the end point, this one's on the top there. That's how magnets would work. This one would repel until they're in line together. So notice that they go in line, spin in line. And this one, if you spin like this, it will just stick. And again, just like magnets. This will literally flip just like this. These are similar. And again, magnet is just rotating ether. This is if you model it like that. So you can model it just by rotation of the ether, as we've done. And I will show this. I'll put this as well, because this is, again, these are bombshell stuff, guys. Like, this is like y'all ain't ready for this. Actually, I'll put a link to this Hive notes. It includes the screenshots. The screenshots are pretty cool. All right, and I'll put it here as well. And yeah, I'll put it like that. High reputation. This one, copy, and paste it like that. A C-shaped motionless electromagnetic generator with Arduino on center point coil will detect the flux of ether. You can read out. Interesting. Makes a really nice vortex. Okay, epic stuff. Let me know if you can produce that and send it to me. make a video and stuff. And a lot of people do cool stuff, but it's like, just videotape it so we can upload it on my channel. Anyways, yeah. So basically, surface waves. Yeah, that's better wording. Surface waves on a conductor will produce rotation of the fluid around it, and that's not a theory. That's literally what would happen, and that's according to this fluid dynamics model that he produced. Like, just basically computational fluid dynamics, and which apparently most of the supercomputers are focused on. Okay, so we have that. All right. Where was okay? Perhaps the closest to this theory came the description of the propagation of electricity in a wire as similar to the propagation of sound through an elastic body, or by the propagation of motion through a series of ivory balls. So this was from I7. This is De la Rive, a treatise on electricity in theory and practice in 3 volumes. Longman, Brown, and Longman's. Anyways, in connection with the magnetic field of the electric current, it is interesting to mention here William Thomson's strong belief that in the interior of a current-carrying solenoid, just basically a coil, the ether rotates continuously or through a definite angle. He could not tell which of these two actually occurred. So was that an angle or? But so Lord Kelvin guy literally believed if you have a current coil, a current going through a coil, like a solenoid or a coil, it literally is rotating the ether. It doesn't know at an angle or just perfectly there. The amount of rotation depends on the strength of the current. So basically, strength of the current, different rotation, faster rotation. William Thomson's mathematical and physical papers. This again from this page 503 to 504. I must note before we look at this quote that I consider quite unreasonably William Thomson's assumptions that the ether had rotational rigidity, and that electric fluid drags the ether. Basically, he's saying that the electric fluid, but in this case, it doesn't drag the. William Thomson's saying that it drags the ether and that it had rotational rigidity. Basically, I think it meant. I'm trying to say, I think basically it has like it prevents rotation. So if you want to try to rotate it, doesn't want to do it. It's kind of like sticky. Like imagine your arm trying to twist your arm. You have that rigidity, but according to Ionel Dinu, he's saying it's this frictionless. The ether is frictionless blob. Like basically, all the substances are there's no stickiness to them. They're just completely yeah, frictionless. It's not like syrup or any liquid. Just basically think of water, but like even with less viscosity, with zero viscosity. So they completely are like melt through everything, or just fall down through everything. Anyways, imagine a continuous. This is another thing I need to update. Imagine a imagine. Okay, so I need to fix this one up. Delete space. Okay. Yeah, so this is a good thing I have to fix. I'll try almost no current as to make it behave superconducting. Yeah, basically, like, think of that. That's just the Aether one. Churl, okay. Yes. Yeah, Walter Russell's another person. I've seen it. It's pretty interesting stuff there. He has some interesting stuff, but again, I will eventually get to that. But I'm a very practical person. Like this one here is like the first to get to the theory part, and I think this guy's got it. I must note before we look at this quote that I consider quite unreasonable William Thomson's assumption that the ether had rotational rigidity, and that electric fluid drags ether. Imagine this figure 2. This is from William Thomson. Figure 2 or 3 to be the section of an ordinary helix or solenoid with a solid copper core. So you have solid copper core inside, and now this is the ordinary helix, basically a coil. Imagine a continuous electric current or an alternating current. So this is alternating. This goes in, out, of electricity. Okay, of interesting. Okay. Sent through the solenoid, shown in section by the outer circle. Yeah, so like this is continuous like that. Whatever the current of electricity may be, I believe this is a reality. This is again Lord Kelvin, William Thomson. I believe this is a reality. It does pull the ether around. So he's saying that it's pulling the ether around within the solenoid. I do not think this is a dream of electromagnetic theory, difficult as the idea is. I believe it to be reality. Whatever ether is, we move through it. The Earth moves through it somehow or other. I just want to check what year he's born, actually. Lord Kelvin. Because he's talking about ether. He died in 1907. And then when is the Einstein relativity? Einstein relativity stuff. Okay, and then this was a photoelectric effect he was dealing in 1921. And then when was it? Yeah, so he was okay. Anyways, so he's doing stuff like that. I just want to see because this was just before the Einstein stuff. He was saying that we moved through the ether. Okay, and then so somehow or other, however it is, the ether is pulled around. The ether does get a turning motion in the interior of a solenoid. Somehow or other, the electric current through the surrounding wire does give a turning motion to ether in our supposed copper core, and then the air between it and the wire through the current is flowing. Yeah, so somehow it does give a turning motion to the ether. So basically, it's saying it's rotating ether. And now instead of alternating current through the helix, take a constant current through it. What can it do? One thing or the other. It does. It does either a constant current through this helix drags the ether round and round inside, or it drags it round to a certain angle proportionate to the strength of the electric current and brings it to static equilibrium, so termed. It does either one or other of those things. Okay, so I will end this. That was Lord Kelvin talking about that. I'll end this rather historically scented introduction with the prophecy William Thomson made at the end of the 1889 address on the topic of a mechanical theory of electricity and magnetism, I9, and we'll get to that in a bit. And with my comment that the present work might be the fulfillment of his prophecy. So Lord Kelvin, in 1889, at the end of his address on the topic of a mechanical theory of electricity and magnetism, he made a prophecy saying that, and here I am, I'm afraid I must end by saying that the difficulties are so great in the forming of anything like a comprehensive theory that we cannot even imagine a finger post pointing to a way that can lead us towards the explanation. That is not putting it too strongly. I only say we cannot now imagine it, but this time next year, this time 10 years, this time 100 years, probably will be just as easy as we think it is to understand that glass of water. Yeah, it just as easy as we think it is to understand that glass of water, which seems now so plain and simple. It cannot doubt but that these things, which now seem so mysterious, will be no mysteries at all, that the scales will fall from our eyes, that we shall learn to look on things in a different way, when that which is now a difficulty will be the only common sense and intelligible way of looking at the subject. Again, there's some possible Freemasonic talk saying maybe in 100 years we'll let you guys know. Anyways, I ask you to pardon me for leading you to so impotent a conclusion as to that we really know nothing below the surface of this grand subject which constitutes the province of the institution of electrical engineers. So he's literally admitting we don't know nothing. William Thompson, Mathematical and Physical Papers, Volume 3, Cambridge University Press, again, page 500. So in this year, the year 2024 is when he wrote it on a solar eclipse. This time 100 years, William Thompson prophesied about in his 1889 address quoted above. Yeah, he's saying, is this the year 2024, the 100 years, and is the present work, albeit 35 years later than prophesied, going to be the one showing how to, quote, look on things in a different way, the only common sense and intelligible way of looking at the subject of electrostatics? I can only hope that what follows will, in William Thompson's words, make the scales fall from our eyes. Again, this is Ionel Dinu dropping some lyrical bombs, some philosophical gems right here. All right, let's lower this right here. All right, yeah, Calvin is an OG of science. Yeah, this is big stuff. Yeah, I'm gonna just lower my desk, and then last 30 minutes or so we'll read the next section of this. And again, if you guys have any science specific questions you need or math stuff, let me know. And I'll be trying to do more of my 1-4 math videos for the. All right. All right. Anyways, let's go back here now. This is the other part I think that's missing. So as much as the ether is like everybody talks about ether, but it's like what is the actual thing that's forcing the specific behaviors of electrostatics and electromagnetism and electrogravity, and that's this effluvium thingy. So anyways, the effluvium and the 2,000-year-old problem of explaining electrostatics mechanically. Have you ever wondered how scientists who observed and wrote about electrostatic phenomenon since Plutarch almost 2,000 years ago have actually attempted to explain what they were seeing? So Duan Laurel, this is the development of the concept of electric charge. They were all, without exception, discussing the effluvium. I'm going to see how to pronounce this.
Effluvium. Effluvium.
Okay, so effluvium.
Effluvium.
Okay, so effluvium. I'll go see that again. Yeah, so effluvium, or emanation, a type of fluid the electric object seems to emit in all directions. For how else could the electric object act on another object at a distance away from it? So this is the effluvium thingy that the people were discussing. So again, as much as ether is talked about, this one is not talked about much as at all. Okay. Yeah, so they were all without exceptions discussing the effluvium or emanation, a type of fluid the electrical object seemed to emit in all directions. For how else could the electric object act on another object at a distance away from it? Of course, this fluid was invisible, but the idea of effluvium was important because it was employed to give a mechanical explanation of the attractions that were observed. Initially, it was believed that the effluvium displaced the air around the charged object, and that the air pressure imbalance thus created force. Basically, effluvium displaced the air, so moves it away from it, around an object, and that the air pressure imbalance thus created force. Created forced any near object towards your charged object. Later, when the same interactions were observed by Robert Boyle to take place in vacuum, so this is in vacuum. So now you can say it's not relating to air pressure. It became clear that it was not the air, but the ether that played a role in the observed interactions. Since the ether was believed to remain in the space of Torsyllian vacuum. Basically, just that vacuum when you remove a glass thingy with it. Unsurprisingly, the author of the three laws of mechanics, Isaac Newton, attempted a mechanical explanation of the electrostatic attraction with the help of an elastic fluid emitted by the electrical object. So this is a fluffium thingy, and this one is its own topic. Almost. Let's go wiki. And also go to the electrostatics. Go to electrostatic induction, or just this one right here. So basically, the previous theory was that there was a fluid around all objects, and somehow it can displace the air if you move it or displace the air, and now you can have like some sort of air pressure between it. So we'll have like so imagine there's like a vacuum around me, so everything is going to be wanting to attract into that vacuum. So when you displace it, so it's kind of that's the attraction. But then it's done not in a vacuum. I mean, it's done in a vacuum, so doesn't so it takes it over. Yeah, so basically explains it's not the air, it's the ether. Okay, and the other one I want to go was Torsyllian vacuum. This was that vacuum thingy that they're. And again, I like doing just a quick Wikipedia. Oh, there's the affilium. Pathological loss of hair in the antigen. Okay, interesting. Okay, so why is it not doing science? Other unless stated. Okay, heretic is a level found. Okay, this is a heretic. Visible is an invisible emanation. Offensive. Why is there nobody talking about this mainstream? Interesting. So this is like the big one then. So the big one is not the ether. The big one is this thing because ether, everybody knows about ether. That's like common sense. Like even the mainstream, like you obviously know it's a quantum fluid. It's just ether. String theory is just ether. All right, everything's just ether. But the other one. So this one's Torsylli's experiment was invented in Pisa, 1643. It had basically invented mercury barometer. You just had a glass tube, so you there's no access to air besides the bottom. And then basically this goes down and then until there's a big gap where this negative pressure, because the air is being there's become a vacuum as this mercury goes down, it's gonna start pulling up. Yeah. So anyways, okay. Let's go back here. Yeah, so unsurprisingly, the author of the three laws of mechanics, Isaac Newton, attempted a mechanical explanation of the electrostatic attraction with the help of an elastic fluid emitted by the electrical object. So even Isaac Newton. So John Tyndall, lesson electricity, right here. William Snow Harris, rudimentary electricity. Park Benjamin, the age of electricity. These are all the references by the Isaac Newton one, and this stuff right here. Age of electricity from amber soul to telephone. Charles Scribner's sons, New York, and so on. Anyways, so that is again electrostatic. Excited rods attracting light body. So how is this attracting it? And even in a vacuum will do that. So that's the next one. So that's the ether. Frictional electricity right there. Lungs green. Okay, so as incredible as it may seem, more than 100 years later had to pass between the first scientific investigation of electricity by Gilbert in 1600 and that of electrostatic repulsion by Gray and Dufay in 1733. So we have in the year, what is it? Year 2000. Almost 2,000 years ago. So we got 2,000 years ago. They were talking about effluvium, whatever, and then you got 1600. Now they're doing an experiment and investigation of electricity, and then electrostatic repulsion was 100 years after, 133. Like that's ridiculous. Like how could it take that long before someone's talking about repulsion? All right. Okay, we have a pretty big discussion going on in here. All right, and I had a notification here. Anyways, so as incredible as it may seem, more than 100 years had passed between the first scientific investigation of electricity by Gilbert in 1600 and that of electrostatic repulsion by Gray and Dufay in 1733. So here's this paper, the Cabinet Cyclopedia. A manual of electricity, magnetism, and meteorology, 1841. So thus it can be said that the proper study of the electrostatic repulsion had been overlooked for about 16 centuries. So yeah, the first 16 centuries. This would be the 16th century because first century would be basically 0. Yeah, basically 0 to 100, and second would be 100 to 200. Yeah, so this would be. Would this be considered 16th? Yeah. So then this would be the 17th century, or what would that be? I'm just trying to think. 0 to 100 is first century. 1 to 200 is second century. Yeah, so then this would be the 15th century to no, this is 16th, this is 15th, yeah, 15th to the 16th, 16th century would be, I'm trying to think, how does that be? Okay, 16th century. Yeah, I sound like how it's done. Okay, 16th century is, okay, yeah, so basically 15th, and ends, yeah, so 15th, yeah, so basically up to the, at least 15th, so 16th century, that's the ending of it. This would be 17th century. So basically, it can be said that the proper study of the electrostatic repulsion had been overlooked for about 16 centuries or 17. That's repulsion. This one is 1733. Investigating electricity was this one. So it could be said that the proper study of electrostatic in mainstream physics, in mainstream, because you probably have some deep Freemasonic occultists doing this. So it can be said that the proper study of the electrostatic repulsion has been overlooked for about 16 centuries. If we count since the time of Plutarch in the year 100 AD, when people attempted their first explanations of the electrostatic force, Benjamin Franklin. Oh no, that's when you include this one here. If we count that, yeah. 180. That's from there because it's saying Plutarch was 180. Oh, that's why. Okay, so 16th centuries. So this is 17th century, but he's counting from the time of Plutarch in 180. And that's I1, a history of the theories of ether and electricity from the age of Descartes to the close of the 19th century. Longscreen and Coe in London, so 1910. So when people attempted their first explanations of the electrostatic force, Benjamin Franklin, in spite of this of his extensive researches in electricity, was, quote, perplexed when he learned that electrostatic repulsion existed between two bodies resonating electrified. So you can have repulsion, not just attraction. And attraction, they did look at it, and then they didn't really look at it for basically 1500 years later, and then 1600 years later is when repulsion was they finally looked at. That's fascinating. And even Benjamin Franklin was surprised. And again, Benjamin Franklin, always keep in mind, Benjamin Franklin. Okay, this to me points to ether not being something necessary to explain observed phenomena. Of course, it depends on how we define ether. What do you think is the definition of the ether? What does this experiment clearly shows? To me, is that particles of water can create something akin to magnetic phenomena. Yeah, no, that definitely. So we don't need an ether to explain how magnetic effects come about. We could use real particles that can detect somehow, like photons, for example. If there are photons in a translation and rotation around us, and if we get a material that organizes photons in the air, space, in the way experiments shows, it seems possible to me that we can observe some type of magnetic effects. Yeah, no, what I'm saying, this fluid-like behavior. It doesn't, and also photons, we've seen by the work, they don't exist. They are literally just abstractions from the anomaly of the quantized light mumbo jumbo. So you can see the other part here. I'm gonna go back. That's this one here. This was the photon. I think this was the modified unit analysis. Planck scans. And again, photons is just it just arises from a mistaken view of, basically a mistaken view of the Planck's constant where they had the units wrong. They included random second. So all the photons are, the reason people think of photons is because they've taken 1 second of frequency of light and they say that's a photon. It's just a second. It doesn't mean anything. Okay. Yeah, but anyways, the photons don't exist. So this shows that the ether is a fluid dynamic model is pretty good. Anyways, that's next level. So anyways, I want to search. There was another thing I wanted to search, but anyways, let's continue on. Oh yeah, this is Benjamin Franklin one. So Benjamin Franklin, right here. Benjamin Franklin. So 1751. Remember, Benjamin Franklin saying he was surprised at repulsion. So this is in 1751, and this in 1733 was the first like actual study of electrostatic repulsion by these guys. But then Benjamin Franklin was still surprised. So he was perplexed when he learned that electrostatic repulsion existed between two bodies resonantly electrified. What in the world does that mean? Resinously. Of relating to, resembling, containing, or derived from resin. Okay, pine trees, resinous. Okay, that's interesting. Yeah, okay, so something electrified like that. But going back to this one, so again, this is the same Benjamin Franklin. Experiments and observations on electricity made at Philadelphia in America in 1751. He's literally talking about cold fusion. He literally mentions cold fusion and lightning strikes. Metals are often melted by lightning, though perhaps not from heat in the lightning, nor altogether from agitated fire in the metals. For as whatever body can insinuate itself between the particles of metal and overcome the attraction by which they cohere, as sun-dry menstrue can, will make the solid become a fluid, as well as fire, yet without heating. So the electrical fire or lightning, creating a violent repulsion between the particles of metal it passed through. The metal is fused. Talking about fused metal in people's pockets and so on. To be in a bit here. If you would by violent fire melt off the end of a nail, which is half driven into a door, the heat given the whole nail before a part would melt must burn the board it sticks in, and the melted part would burn the floor it dropped on. But if a sword could be melted in the scabbard and money in the man's pocket by lightning without burning either, it must be a cold fusion. Okay, this is the same guy, 1751. He's talking about cold fusion. It's like mind-boggling stuff here. Okay, I'm gonna put it right here. And again, but he was perplexed as static objects in repulsion. So that's quite well. Guys, keep going. So this is from Edmund Woodtaker, A History of the Theories of Ether and Electricity from the Age of Descartes and so on. And let's continue further. Bob Greer goes into the antique and ancient aspects of technology. There's a trail. Yeah, possibly, but again, just you gotta be very careful with that, and especially if you have Ashley Forbes on the show. Anyways, it's all right. Just let me know basically what I like doing is it's like let me know the most bombshell info you can find from the history antique stuff, and let me know that one, and then once we get one thing we can all agree that it's next level, then we go further. Similar to 9/11, I showed Tower Turn Dust. It's like nothing else you need to. It's like once we all agree, we can go a step further. So in other words, free energies exist, and that's why I am doing these videos, because I don't go out of my way unless there's a reason. Okay, so electrostatic repulsion was difficult to explain in a science whose name. So one second, I'm just gonna quickly check how's my. Because I have to look when I look here. I'm gonna move it like this. Okay, how's my face there? Okay, that's pretty good. There's a giant beard. Okay, there it is. All right, guys. Okay, epic stuff there. I move it away. So electrostatic repulsion was difficult to explain in a science whose name, electricity, entered the English language as a, quote, power to attract straws or light bodies. The science of electricity has had a complicated development, and one of the reasons for this complication was Defay's introduction of the idea of existence of two kinds of electricity to explain electrostatic repulsion. Yes, I had a complicated one reason. Yeah, so this guy was saying there's two kinds of electricity, and this was in the 1733, Defay 1733, where even the cold fusion noticer, Benjamin Franklin is a Freemason probably. Let's see, he's definitely a Freemason. Let's go Freemason. I think Wiki. I think he's definitely a Freemason. Pretty much all the founding fathers were some Illuminati Freemason. Yeah, Freemason. Okay, it was initiated into the local Masonic lodge. He became a Grand Master, 1734. The year after think about it, he became a Grand Master the year after the Fay guy covered electricity in repulsion, indicating his rapid rise to prominence in Pennsylvania. The same year, indicating his rapid. Wonder why. The same year, he edited and published the first Masonic book in the Americas, a reprint of James Addison's Constitutions of the Freemasons. He was secretary of the St. John's Lodge in Philadelphia from 1735 to 1738. He appeared as witness in a manslaughter trial between two men who killed a, quote, a simple-minded apprentice named Daniel Reese in a fake Masonic initiation gone wrong. Fake Masonic. Wait up. Wait up. What in the world are we reading right here? So in January 1733, I'm gonna actually duplicate this. You can do a duplicate thing. Duplicate. I'm gonna put this here to my later tab. He's into a lot of esoteric stuff. I'm missing out on the chat as I'm helping my son rebuild two doors and try to better stabilize the body. No problems. I have a good one. We'll be powering through for another 10 minutes. So wait. It's like this guy has cold fusion. And he's doing all this jazz. And in January 1738, Franklin appeared as witness in a manslaughter trial against two men who killed a quote simple-minded apprentice named Daniel Reese in a fake Masonic initiation gone wrong. One of the men threw or accidentally spilled the burning spirits, and Daniel Reese died of burns 2 days later, while Franklin did not directly participate in the hazing that led to his death. So what kind of... Oh man, listen... In Reese's death, he knew of the hazing before it turned fatal, and it did nothing to stop. Did nothing. He was criticized for his inaction to the in the American Weekly Mercury by publishing rival Andrew Burford. Ultimately, Franklin replied in his own defense in the Gazette. He remained a Freemason for the rest of his life. So the hazing one includes like literally killing someone, and this isn't the first time. So Freemasonic ritual gone wrong. So this is first time. The twins' initiation and murders. Yeah, so it says trust us. Masonic ritual ends in gunshot tragedy. For years, initiation in the inner circle of Southside Masonic Lodge followed predictable peculiar one. So they would have two blanks, loaded with blanks in his gun, and then apparently, and then he was released without bail. Appearing in court this week wearing he appeared wearing a blue Masonic jacket to plead not guilty to the second. Anyways, incredible cell phone. It means the guardian can't be. Oh no, it's this one right here. Yeah, he reached for his right hand and shot. In a distracted moment, he reached for his right pocket and shot William James, 47, dead. So yeah. Had .22 with blanks in his had a .22 millimeter in a blanks in his left pocket, but a .32 with live ammunition or is it inches or millimeter? Anyways, .32 with live ammunition and distract him when he got the wrong one. So this is like wild. I think I covered something like this. Free Masonic gun mnemonic ritual. Yeah, this one here. Throwback. A ritual fatality gone wrong. Throwback when a Freemason accidentally shot and killed another Mason during an initiation ceremony. So like what in the world are we on right now? Okay, I'm gonna paste this here. I'm gonna paste this here as well. Did I forget to paste? Oh, I think I forgot to paste another one there. I'm gonna paste that there. Anyways, we're on a pasting streak. Let's copy a message link, put that in here. And then Benjamin Franklin. Think about the U.S. founding father. It's like literally like knows, but there's gonna be a hazing. They're gonna throw like boiling water in someone's face and like kill him, and he's like chilling like a villain. I'm gonna make this yeah, this is just. I'm gonna see how do I like highlight this part. Okay, anyways. I'll just put it right here. Hazing. Alright. So we're on another level, guys. So, alright. And this guy's got a cold fusion and so on. Okay, anyways, let's keep going, guys. We have 5 minutes or so. like what is going on here? I'm out here reading with the Aether. Now we got Freemason US founding fathers thrown like on trial for like allowing pretty much Freemasons like kill each other in a ritual. And I think they do these rituals, these killing ones, to see like how big of a psychopath are you. If you're willing to like kill your own fellow Freemason, then you could be trusted to to run the country and like kill millions of people, or like starve millions or enslave millions. Anyways, so basically it's like a rooting out the psychopaths. Why was Satanic sunk to thwart Tesla via killing all investors? Anyways, why did JP Morgan go to ship? Yeah, it's a lot of stuff. Okay, ego out. Okay, it's good. How are you, Matt? How are you? Ego out. Hope you're doing well. Anyways, we just went over some Freemasonic rituals. Franklin was like a founding father spy. He had many connections going on. Yeah, it's a founding father. Again, these are all a bunch of illumined creeps. I think that's a good term for the Freemasons. Anyways, electrosonic repulsion was difficult to explain in a science. Yeah, okay, it's part of right here. So the science of electricity has had a complicated development, and one of the reasons for this complication was DeFay's introduction of the idea of existence of two kinds of electricity to explain electrostatic repulsion. The development of the concept of electric charge. Okay, this was a Harvard Press, 1954. It can be said that DeFay's introduction is in 1733. Introduction of the idea of existence of two kinds of electricity almost put to an end the whole effort of finding an explanation of the electrostatic interactions, because his view implied that the two kinds of electricities acted on one another at a distance. So this is where pretty much, and at the same time, well, a year after Benjamin Franklin gets a Freemasonic Grand Master degree. So doesn't that remind you of a famous actor accidentally shot a gal on the set? Yeah, that was the one that was Trump was like the anti-Trump guy. Then Trump started tweeting about him. So it's like really weird. And that was another part of the predictions where I realized, okay, Trump's gonna do a fake assassination. Yeah, there was that guy. I forgot his name. It was it can be said that the yeah, this right here. So this pretty much put the end to the mechanical explanation. Mechanical basically means full, accurate, true explanation, not a placeholder. So like charges are placeholders. Particles are placeholders. Particle of what? Okay, that's a placeholder. Trillion dollars go missing, and the office of Pentagon was also investigated because blown up. Yeah. It was keep it. Also note it was trillions of dollars of transactions. So it's not necessarily dollars. Because no one's gonna dispute 2 trillion. Because they usually they'll say they give it to the army and so on. It was transactions. So basically, they didn't know what they were transacting back and forth, like 2 trillion amounts. So it is pretty wild, yeah, but it's not as world changing as 2 trillion, like actual money gone. So to make matters worse, the concept of effluvium, more money spent on war and drugs than all U.S. wars combined have wide budget. Interesting. Yeah, but again, U.S. Army gets $1 trillion a year. So to make matters worse, the concept of effluvium, so that was the thing that was emanating and so on, seemed to give contradictory explanations in the case of electrostatic repulsion. Yeah, that's because this was developed to explain extraction, but now you have repulsion. How are you going to do that? For how to explain repulsion between two electrical body objects, if they both emit and especially if they both absorb effluvium. Effluvium is nevertheless an important concept to return to and reconsider because it is a healthy scientific concept being derived from a healthy and legitimate way of scientific reasoning, something that the experimenters of the past worked so much with their effort to find a mechanical explanation of electrostatic interactions. And effluvium is relevant because it naturally led to the development of the theory advanced in this work, which theory, however, makes no use of effluvium at all. How is this possible? First, effluvium is related to the fact that the electrostatic force is a short-range force, unlike the gravitational force, which acts through the vast distances of the interplanetary space. So although both forces act through the ether, they are not similar because they do not act through the same mechanism. The gravitational force was identified in I9. This was the origin of gravitation. That's something we could discuss as well. As a buoyancy force in the ether. So yeah, that is basically it. Buoyancy in the ether. The ether pressure gradient necessary for its action being produced by the total radiation emitted by a star or planet. So the gravitational force was identified as a buoyancy force in ether. The ether pressure was pressure gradient necessary for its action being produced by the total radiation emitted by the star. Again, so as it starts, it's emitting and so on, you're gonna have this effect there. But that'll be something for. Let's see if I can find this exact paper. That'll be something for another one. Okay, origin gravitation PDF. And this is why we can do that object falling. See some photos he has in here. He went. What I like about him, he actually goes over the math and basically rewrites the mainstream physics stuff in terms of fluid dynamics. And where is he going over here? Okay, but I just want to see some images. Okay, that's something to look at. I'll put this as well. That's something for, anyways, that'll be for another day. I'll put this here, gravitation, origin of gravitation. So he's writing a whole lot. But again, what I do want is if is to like basically put it all in one paper. So I don't like the whole idea of papers like necessarily. I want to put them all like almost in one go. But no, it has its purpose actually. Never mind. But I just like having like the final theory. Like for example, Ether should have a full ginormous book here on Hive blockchain, and we can edit any updates and so on, or correct any corrections. Anyways, the short-range feature of the electrostatic force is well captured in the concept of effluvium, because the effluvium as something emitted by the charged object cannot be expected to travel too far through the ether from the object that it emitted. As something emitted from the charge. So charged object is emitting something. That's the thing. That's the key. However, it is not reasonable to admit that the charged object emitting effluvium continuously, because this would mean that a charged object is an infinite source of effluvium. It follows then that the effluvium emitted by a charged object must return back to the charged object that emitted it, because which is what some investigators in the past actually believed it occurred. Basically, before they're saying this was just emitting always, but that's just basically then just have an infinite store of effluvium whatever, and that's just not gonna work. So it's basically it's stuck in so the effluvium of a charged object is just it has to go back a circle around itself, and if the effluvium is emitted, then returns back, then is emitted again, then it returns back, and so we have a to and fro motion of effluvium that originates at the charged object. If that is the case, then there's no need for effluvium at all, since basically if it's going back and forth, since all the same function can be assigned to the ether surrounding a charged object. So basically an ether surrounding a charged object will be doing the same thing, basically to and fro vibrating surface wave motion. Taking a charged object as an object in a molecular vibration immersed in ether, it can be seen that the ether will be pushed to and fro by the charged object. So taking a charged object as an object in as molecular vibration, so basically vibration. So that's pretty much the ether. I mean that's pretty much the you don't even need the that's pretty much a charged object, just vibration. That's interesting. Taking a charged object as an object in a molecular vibration immersed in ether, it can be seen that the ether will be pushed to and fro by the charged object, and this to and fro motion will act on another object placed at a distance. And that's pretty much this part here. That's this part here. So again, as it vibrates, and will act on other objects. All right. And this will to and fro will act on another object placed at a distance. Thus, what we call an object with quote electric charge is in fact an object charged with energy of vibration. So a charged object it's just vibrating. That's it. So there it is. Okay, we've concluded. So a charged object is just vibrating. There's no positive, negative charge. It's just vibrating. This naturally leads to the conclusion that what we call the electric field surrounding a charged object is in fact a to and fro motion of the ether. So the electric field is just the ether vibrating back and forth due to a vibrating object. Vibrating charge is just an object vibrating. Is in fact the to and fro motion of the ether produced by the vibrations of the object. We have seen in this one here. I'll have to look at this one in this is II10 Ionel Dinu Fundamentals of an Ether Part 2 ResearchGate August 2021. We have seen that in I10 that attractions and repulsions take place between vibrating objects immersed in a liquid. So basically vibrating objects placed in a liquid. And we will see later how the laws of electrostatics can be explained by the coupling of the vibrating objects acting on one another through the ether. So we've seen that attractions and repulsions take place between vibrating objects and immense in a liquid. So not just rotating, vibrating can also get attraction and repulsion. And we've seen later how the laws of electrostatics can be explained by the coupling of the vibrating objects acting on one another through the ether. All right, so this is this was from here. I'll have to search this one up next time. So we'll start off from here. And yeah, part 3. All right, anyways, guys, Epic's up. Hopefully you enjoy this epic stuff here. Static electricity everywhere. People are finally catching on. That's correct. Electricity is straight up vibration. Yeah, I know. I agree. But he has experiments demonstrating. I believe he has experiments demonstrating this, and also theoretical or 3D fluid dynamic models of it. But like, if you can demonstrate it, that pretty much puts something in stone. I saw a preview, but it disappeared. Only read the contents page. Okay. Anyways, guys. Yeah. So this is the big one. Anyways, that's all for today, guys. Hopefully you enjoy this epic stuff there. I'm gonna close some stuff, and we'll get to this. We'll get to this stuff, and we'll start off from the part 3 next week if I'm doing it. I think what date is that? Yeah. Okay, so New Year's is on the Thursday, so yeah, I'll be doing this one on the New Year's Eve. All right, guys. See you on New Year's Eve, and hopefully you enjoy that Judy Wood stream, and we're gonna do another Well, yeah, this week I might do a predictive programming or post predictive programming. Yeah. Anyways, this is gonna be some epic stuff, guys. I'm gonna go right here, close everything, and end the threadcast. All right. So yeah, thanks for joining. And go right here. All right. Thanks for joining, and have a great day, and Merry Christmas. All right. So we only had comments on Rumble and this one. How do sucks? Okay. Have Merry Christmas and so on. Anyway, guys, I'm ending the stream in 3, 2, 1. Adios, muchachos. Ending the stream. Okay, the stream is ended.